In this lesson, we're going to start statistics and we're going to be learning about standard deviation. So there's measures of central tendency in statistics, and those are the mean, the median, and the mode. Really, we'll only be using the average or mean during this unit, and the sample standard deviation goes really well with the average because it's an average measurement of how far the data points are from the mean. So you're measuring the average amount of spread or how far they are on average from that central value. So there's two types of standard deviation. You can calculate one, and that's for a sample. So if you just take part of a group and survey them and find some sort of statistics about them. There's also population standard deviation. They're calculated slightly differently, which is outside of the scope of this course, but basically they're going to be really close, and they just have different spots on the calculator. So one thing that's really nice is on Delta Math, you don't need to get out your graphing calculator. This can all be done in a graphing calculator. You can actually copy the values for the calculator right here, and then you can open the statistics calculator. Let me just erase this section, stuff I'd already written. And then once you open that statistics calculator, you can paste the values. So I should see those values appear, and there's only one list of values, so they're all in L1. So from there, right now we're in Edit Lists. We're going to click this menu and go to the Calc menu, and we're going to choose One Variable Stats. We only have a list 1. There's no frequency list. We will see that on the next example. So I just pressed Calculate. Now, the really 3 measurements that will be important this unit. This one here is sample standard deviation. This is a sigma x. I kind of think of it as like a flipped around p to help me remember that it goes with population standard deviation. And then this one here is mean, which we'll be using later in the lesson. So this one asked for sample standard deviation. So I forget what it said to round to, so we'll go back to that. So I pressed my back button and I'm back here now. So I had a lot of things I was pointing to. I'll try to be a little more smooth about this on my next example. So this says nearest thousandth. So back on that menu, it was 16.351 was your answer, and that's what you would type in. So we're going to start to look at the next example. And I should have mentioned, I think you guys can figure this out, we're on lesson 101, so this was just page 7 in your packet, and you can see all of those different menus. On the next few questions, I'm not going to be putting the menus down. I'm just going to show the problems, but on that one, you can kind of look back at the things you should click on. So now we are actually going to the next page. So on this example, we are looking for the population standard deviation. So what that means is whatever this study was about, this data was collected from every single thing that they wanted to study. We also see a frequency table, so this means that there are 5 9s, 1 10, 2 13s. This is the only time I'm really going to write out what that would look like. So if we wrote these out fully, 5 9s, 1 10, 2 13s, and so on. So the frequency table just kind of condenses things, and we can actually copy that for the calculator, which I'm going to do right now. So I'm going to click Copy Values for Calculator, then I'm going to open my statistics calculator, and then we'll scroll down the page a little bit. Do not know where my copier. Okay, I think since I hadn't actually copied them, it didn't register, so I didn't see this paste button. But now we see it, so we can press it, and you see I get my full 2 lists. We're going to go to the same place in the Calc menu. It's still One Variable Stats because we're really just measuring one thing. We just have frequencies for that one thing. So now with my frequency list, I'm going to click down and pick L2, and then click Calculate. So this asked for the population standard deviation, which I see right here. And rounding to the nearest 10th for this one, I think it said. I'll look again. Nearest 100th for this one, so we have 10.38, and we'll go put that answer down back on the page. So now that we're here, we would just write down 10.38 and then submit your answer. So there is a second type of problem we're going to be using this same concept, but then also finding percentages of values that fall within either 1 or 2 standard deviations of the mean. So I'm going to switch over to that section now. So in this problem it says, for the following set of data, find the percentage of data within 1 population standard deviation of the mean. So first we have to actually find the population standard deviation and the mean. Now, looking at the values that are given to me, these are all rounded to the nearest whole number, so finding the population standard deviation and mean aren't really answers that I have to report anywhere, but usually I'll take one more digit of accuracy than this data, and that'll be enough to make sure that things work out correctly. So when I go in, I'm going to copy the values to my calculator, or for the calculator, open the statistics calculator, paste the values. We have one list, so then I go to the calculate menu, one variable stats, we just have an L1, and I click calculate. So I see that the mean here, and I'll write this down, we'll bring it over to the other page, the mean is 71.6, and this one said population standard deviation, so we use this one. So sigma x, or population standard deviation, is 4.8. So going back to the question, we had that the standard deviation, let me go back to my pen, or the mean was 71.6, population standard deviation 4.8. We want to go, what percentage is within 1 standard deviation of the mean? So this within 1, or we'll see within 2 as well, means that we're adding and subtracting the 4.8 or the standard deviation from the mean. So we're doing 71.6 minus 4.8 and 71.6 plus 4.8. So that's going to give us our range that we're looking between. So subtracting, we get 66, sorry about that, 66.8, and adding it on, we get 76.4. So we're looking for scores that are between these two numbers, or between 66.8 and 76.4. So 66 is too small, I'm not going to count that one. 82 is too big, I'm not going to count that one. 69 is fine, right? That's in between these two values. 74, 71, 74, 70, and 67. So to find the percentage that's within 1 population standard deviation of the mean, I just count these up. 1, 2, 3, 4, 5, 6. So there are 6 of them out of a total of 8 values times 100. So that's going to give me 75%. It says to the nearest percent. We already have nearest percent here, so I would just type in 75 down here and then submit my answer. So in this last problem, we're back to a frequency table. This time it says, for the following set of data, find the percentage of data within 2 population standard deviations of the mean to the nearest tenth of a percent. So I'm going to start out, I need population standard deviation and the mean, so I will copy the values for the calculator, and then open the statistics calculator, paste those values. We'll go to the calc menu, one variable stats, and we do have a frequency list, so I'm going to put that in. And I press calculate. So here I see that my mean to the nearest tenth is about 35.0, and the population standard deviation is about 6.9. Now, same deal here. We could kind of pick our rounding. Basically, I'm just going to use tenth again here. So going to the next page, and actually, you know what? So going back to the problem, I'm going to write those values down. So we have the mean is about 35.0, and the population standard deviation is about 6.9. So now we're going within 2 standard deviations of the mean. So we're going to take the mean and subtract 2 standard deviations, and also the mean and add 2 standard deviations. So I would probably, I could use my phone for this, or I could get out my graphing calculator to type in these 2 parts. Basically, when I add it twice, I am going to get 48.8 here. And then when I subtract it twice, oops, I did those backwards. Let me just erase that. So my 48.8 actually needs to go down here, right? Because that's the adding, that's the getting bigger number. And then here, if I did this calculation, I would get 21.2. So looking at my data over here, if I start with 21.2, that value would go right in here. And if I go all the way up to 48.8, that actually includes all of the data down here. And I am expecting a larger percentage to be included because I'm going out 2 standard deviations versus the one I did on the other problem. So all of these values fall within 2 standard deviations of the mean. Now it's tempting to say, well, I have 1, 2, 3, 4, 5, 6, 7 values here, right? Out of 8, and just doing 7 out of 8, but we have to consider the frequencies. So if I add up these frequencies here, it ends up that there are 66 values. So that's just 6 plus 9 plus 14 and so on. I'm adding up these numbers. And that's 66. There's only one that's on the outside. So that's 66 out of 67 times 100 comes out to be 98.5%. So you don't need to enter the percent when you enter in your answer because it already says that word percent up here. So I would type in 98.5. Let me just get back to my pen. Down here is my answer.